All right, welcome back. We are COMP301 in the summer 2020 semester at Centennial, and it's week 10, part 2 of our broadcast. We're talking about more data science and dynamic visualizations. Last week we talked about static visualizations with Python, and today we're going to be talking about dynamic visualizations. So before we get going, I'm just going to spin up my VM. Let's do that right now. Some people are reporting that they're having problems with their VirtualBox, not just one person, but a couple people. And as I said to you before, there's also an option for Centennial students to use VMware. Okay, so you have access to, to get VMware for yourself. Okay, and if I was going to go into Centennial for a second, so here's our Centennial. When you enter Centennial for the first time, my Centennial, if you look down towards the right, you can see there's something called a Microsoft eStore. This right here. If you click on that, so this is when you enter Centennial as home. On the right, it'll redirect you, and as an example, you click Students, and then you have access to all these software programs because you're a student of Centennial. And you can see there's like a lot of different software as well as something called VMware, right? So VMware is an option. You can certainly go and download Vmware Workstation 12, right? I think it's great. Even though it's the latest version is 15, 12 is perfectly fine. There's nothing wrong with it. Now it says it's like $207, but I'm thinking you can probably get VMware for free. I'm gonna look and see if I can get you a version of VMware. I know that in the recent times this has been a free trial. There's also a free trial that you can try out for a while. One thing is you can always use VMware Player, to when you make a VM. And Vmware Workstation, what it does, allows you to create new VMs, right? So VMware is definitely a way to go. I will look into it for you for maybe next week if I can. I have to talk to a couple of my colleagues and see if they have, if they can have access to this. It's just another link. It's not this link. There's another link that you can use to download and install VMware. So that's what I'm using, because I also found that VirtualBox is kind of flaky at times, and it depends on the system. Like for me, VirtualBox is working, but that's because my system is pretty much clean. But for you, maybe depending on your system itself, and some people are having issues, it could be like hardware issues, right? I don't know. It could also be the way you've configured Windows. If it worked before and suddenly it stopped working, and you've uninstalled it and reinstalled it, sometimes you need to do some additional work, like where you use you go to the registry and uninstall things with the registry. So if anyone's here who has problems with their VirtualBox, if I can get you to hang back after class, and then let's see if we can resolve that issue. Okay? If not, then maybe I can redirect you to something else. Okay, so that's the VirtualBox stuff. So I've got my virtual machine up. Again, I'm using Vmware Workstation 15, and I'm using a teacher version of this. So that's how this is working. So last day what we did, we talked about sets, and we kind of talked about comprehensions. The last thing we talked about for Python. Again, next week, just a reminder, I'll say it now instead of later. As a reminder for next week, there will be no class on Monday, and there will be, the next time we'll meet together is on next Thursday, and that's when I'm going to be giving you your next assignment. So please expect your last assignment for the semester to be handed out next Thursday at this time. All right, and this is what's going to cover what we're doing in the next part, which is with all the new things that we've been talking about, things like sets and dictionaries and all that. Okay. So here we are back we're in Linux, and I've got my Python installation here in Visual Studio. I'm going to add a new file today, and again, I'm following the tutorial, right, that's inside of your lecture notes. So that's in here, so that if you follow the tutorial, I'm going to go through it as well. What we talked about last time was using a static bar plot with Seaborn and Matplotlib, And I think part of learning how to use Seaborn and Matplotlib, which is a long process, I can tell you I spent many nights trying to configure things with Seaborn and Matplotlib when I had assignments due in university, right? So it might be the same for you if you ever get to do anything with machine learning or data science. So what they talk about here is we want to start rolling a lot. We noticed last time that as we increase the amount of rolls from last week with that random nice number rolling system, that as we increase the numbers to something like 600, beyond 600 I mean, to 6,000, 60,000, and finally 6 million, the law of large numbers brought things into play so that we were close to this 6.667% for the heights of the bars and everything else. They were almost exactly the same, and the reason why is the more times we roll, then the law of large numbers says that we're going to get, for a die roll between 1 and 6, we're going to get a kind of a distribution of about 16.667 each if we have that many rolls. So each one's going to get an equal number approximately of die rolls. So what we're going to do this week is use something called the func animation function in the animation module. Matplotlib has an animation module, and the animation module is going to basically, for people who've done any kind of game building of your own, there's going to be an update function, and the update function is going to trigger X number of times per second. We're going to try and, I think we're targeting 30 frames per second with this visualization this week. And what it's going to do is it'll dynamically change as the rolls happen, okay, which is pretty cool. You'll see the bars animate, okay. So func animation is like a frame-by-frame animation. That's what it does. Frame-by-frame animation gives you the illusion that things are moving, but actually what's happening is the current frame, and think about the frame as an image that you see on your screen, is going to continue to change over time. So as the frames keep flipping, almost like a frame flipping type animation, it's going to give you the illusion of movement, right? Which is the animation effect that they talk about here. So again, each frame, if you think about each frame being a slice of 30 slices of a second, right? That means, again, if we look at a calculator for a second, if I said I want to take a second, which is 1,000 milliseconds, and divide that by 30, then each frame is roughly 33 milliseconds, 33.3333, right? If I was going to do a 60 frame per second animation, then I would take 1,000 milliseconds per second, that's how many milliseconds are in a second, and divide that by 60, which you'd get 16.666667, right? Milliseconds per frame. So each frame, when we talk about frame, is a slice of time. That's what a frame would be defined as, a slice of time. And each of these slices of time, in this case it's going to be 33 milliseconds. Every 33 milliseconds, we're going to roll the dice a number of times, right? We're going to update die frequencies with each roll. We're going to clear the current plot, right? Whatever the current plot looks like. Create a new set of bars. So we're going to destroy what was there already, create new sets of bars every 33 milliseconds, right? Then create new frequency and percentage numbers, and we're going to put them on the plot. And it's going to happen every frame. So again, every frame is 33 milliseconds approximately, if we're going to run 30 frames per second. So that's how the animation effect is going to take hold, okay? Again, I think what they talk about is true, which is frames per second. The more frames per second yields a smoother animation, right? Most video games go at least 30 frames per second. Now, I think that's minimal, right? Even with my RTX 2060 Super that I have as a temporary card right now from my system, I can run ray tracing around 30 frames per second, at full pop, 4K video, right? So that's pretty cool. And for a lot of games, like for especially some older games that are not frame limited, frame limiting is like, I want to cap you out at a certain frame rate, as an example. Frame rate means how many frames per second, how many slices of a second can I have, right? And this is all hardware dependent. The more beefier your hardware is, the more frames per second typically that you can, your video card will output. Now, if we're using a standard laptop, and that means when I say standard laptop, which means something that has a video card with less than 2 gigabytes of RAM, that's a standard laptop these days, because it's not a gaming laptop. You don't want to do, you're not doing gaming with it or whatever. Going beyond 60 frames per second, depending on the game, can be really challenging. So, at the same time, we're doing calculations, and we're talking a lot of calculations every frame, right? So again, think about this. If our animation frame rate is every 33 milliseconds, right? And again, we have about 30 frames per second. Every second we have 30 instances of an update every second. So it creates that animation effect as if things are moving. The larger this number is, and we can change the frame rate later, then the more beefier your hardware has to be in order for you to handle more calculations. Again, we can experiment and adjust our frame rate as well as the number of calculations we're going to make per second. So again, what we want to do this time is we want to make a bar plot that has our final frequencies and percentages. This is what we did last time, right? But we're going to do this frequencies and percentages that are going to be drawn for the lifetime of the calculations. So for example, let's say our calculations, we want to go to 60,000 rolls or 6 million rolls. Remember that when we did our calculations from last day, and let me just show you that. So I go back to my Linux installation here, right? And let's bring up last day's kind of code, right? So we had last week we did this one, right? COMP301 lesson 9. And if I bring that up, so if I bring up Visual Studio Code and open up last week's, just to do a comparison. So I go File, I'm going to open my folder, and I'm going to go to last week's folder, right? If I open this folder up and look at barplot.py, and if I was to run, if I said something like, Python and then main.py, right? Then you can take time to roll 60,000 signs. See that delay that we just had there from the time I press this button or press enter to the time this came up? And this is for 60,000 rolls, right? If I went to 600,000 rolls, let's go to 600,000 now. So I just added another 0 to D6 plot. This is from last week's work, right? And if I come back and do it again, it's a little bit longer, right? 60,000. Well, actually, right now, did I save? Let's try that again. Let's try that again. It kind of took about a second to do, right? 600,000. And when it comes longer is when we say, okay, what about 6 million? For 6 million rolls, what happens then, right? So again, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 4 seconds, right? So in that 4 seconds, we're waiting for this bar chart to come up, right? From last week. And in this case, what we want is for these bars to change over 4 seconds. We want to see movement in here, right? And that means we have to erase everything and redraw everything 30 times every second. So if this normally takes 4 seconds, let's say approximately the same time, times 30, right? 4 times 30 is 120 frames that we're going to see over the 4 second period. 120 times this is going to change, right? It really depends on how many rolls we make per second. Okay, so that's the one thing we're going to also modify. And then if I go beyond 6 million, if I go to 60 million, right, so that's a way bigger number, like an order of magnitude more. If I go there and I type it in, 1, 2, 3, 4, 5, 6, 7, 8. Think about this. I'm not counting. About 20 seconds so far. $30. So 30 seconds. I mean, I'm counting like with my head. It took 30 seconds for me to produce this bar, and I had to wait for everything to come. Notice that the numbers, don't worry about these things, they overlap right now because of the way we drew everything. But notice how all these numbers here are almost very close to the same. 16.664, 16.665, 16.672. The law of large numbers is really playing into it, and we're almost exactly the same at the top now. So we want to see this, but instead of waiting for 30 seconds for something like this to come up, we want to see interactivity. We want to see movement because it's more interesting for us to look at. Okay, that's what the exercise is today, right? So this is from last week that I'm looking at. I'm going to open this week's up. So this week, what we want to do is we want to make a new file, right? And for now, we'll call roll.die_dynamic.py. We'll follow the roll.die_dynamic.py is what they called it in the lesson. And what we want to do here is we want to put a little some documentation that basically says, and a doc string that basically says dynamically graphing frequencies of die rolls. That's what this thing's about. Okay, so that's what this program's about. We want to say from Matplotlib, right, we want to import our animation. All right, that's a new thing. We're importing animation. Remember, the animation has that func animation kind of function that does the animation sequence. We want to also import from Matplotlib, right, .pyplot, like we did last time, as PLT. PLT or plot is the standard. We want to import random. Let's go to the next line. Import random. These are all the setup from last day. Import Seaborn. Come on. Import Seaborn. Now you have to have your installations here for it to happen, and we're going to say as SNS. That's Seaborn. As well as we're going to import something called sys. And the sys allows us to write things out or use the system. So that's our first part. First part is, can I create a in here, kind of, these are all the imports, right, for libraries and stuff that we need. Okay, this is what this is. Let's get back to that PowerPoint presentation for a second. All right, so we want dynamic visualization. We want this to happen in a script, as an example. And the script's going to take 2 command line arguments, number of frames and rolls per frame. So it's going to look like this: Python roll.die_dynamic.py. We're going to have the first thing is the number of frames, and then rolls per frame. Now, this is interesting. If I want to do 6,000 frames, let's think about this. If I say 6,000 frames, this is a different way of thinking. And if I say that I want to do, oops, that's not what I meant to do. 6,000 frames divided by 30 frames per second, it's going to take 200 seconds, which is divided by 60 seconds is roughly 3.3 minutes. So it's going to take 3 minutes for my visualization to complete, right? And rolls per frame, if I have 6,000 frames, I'm going to do, if I do 1 roll per frame, I'm going to have 6,000 rolls. So remember, 6,000 rolls, what it got us, right? It wasn't, the bar graph wasn't that great. We're going to have to roll many, many more times, like 600 rolls per frame, as an example, in order for me to do something better. Because if I take 600 rolls and multiply, I'm just saying 600, I made a number up, 600 times 6,000, then you're looking at 3.6 million in that range, or even more than 600, right? Maybe 1,000 rolls per frame, right? The more rolls per frame, the more beefier the calculations are going to be, which is going to require a bit more time, and calculations per frame are going to increase. So again, you can see that we can run 600 rolls for a longer time. That's another way of doing it. Instead of saying how many frames, well, now we're going 10,000 frames, and 10,000 frames times 600 rolls, right? Again, if that's another way of doing it. So 10,000 frames, right? 10,000 frames. Divide that by 30 frames per second, right? That's going to give us 333 seconds, right? Divide that by 60 seconds per minute is roughly about 5.5 minutes of time that we're going to be spending waiting for this animation to finish, all right? Now, and then in that time frame, if we take our 10,000 frames and we say we're going to do 600 rolls per frame times 600, Now we're going to get to that 6 million mark. That 6 million mark, that's going to give us the law of large numbers. That's why this is the way it's done. So this is a command line thing. And we're going to use argv from a command line perspective to get input from the command line for the first time, right? So that's what this is going to do. Okay. They have some examples on the PowerPoint here of some sample executions. So here's what it's going to look like for 6,000 roles. It starts off as 64 roles. It's going to go to 604 roles. You can see that these things are here. And then finally for larger roles, here's 7,200 roles. You can see that the numbers are the bars are getting more even. And finally they become 166,000 roles here in their simulation. From the book, you can see that the roles kind of become equal, which is pretty good. It makes sense. So again, we did this part already. We're sitting at page 44 of our PowerPoint. We imported all that stuff, and that's the first thing we want to do, import all this stuff. Okay. The next thing we're going to do is write our update function, and the update function is going to be called by the func animation method over and over again. Again, X number of times per frame. Okay, so let's start scaffolding out that function, and the update function really is something that we're going to is kind of our main function. Okay, so it starts off like this. If you actually follow this part, we have we're going to define an update function that has the frame number followed by the roles, followed by the faces, followed by the frequencies. So again, frame number is the next value from func animation's frames argument. We're going to get that in. And then roles, the number of die rolls per animation frame. We're going to get that from our command line. Faces, the die faces values used as labels. So this is going to be like 1, 2, 3, 4, 5, 6. That's what faces are. Frequencies is a list where we summarize the die frequencies. So a list of die frequencies, which are going to be somewhat similar to what we did last time. So let's get that going. I'm going to start doing with this. So again, I'm going to go step by step here so we can do it together. So again, I'm going to define an update function. My update function is going to take frame number. It's also going to have roles, faces, and frequencies, if I'm not wrong. Okay, those are the things we're going to have there. We're going to use the doc string, and the doc string that's here. Actually, let's just undo that. Change. We're not going to. Just going to type the doc string out. Configures bar plot is what they said. Bar plot contents for each animation frame. Okay. Which makes sense. All right. And then we want to put this inside of here because it's going to be any doc string should be inside of the same code block as the function, right? We want to roll die and update frequencies, okay, which is what we're going to do next. And what we're going to say is for I in range of however many rolls we said, then what we're going to do is we're going to say that the frequencies list is going to be a random range. This one, random range of 1 to 7, just like we did last time, right? And then -1, right? And then plus equals to 1. This is the way that they're going to figure this out. Okay, so this is the way. Now remember, what we also want to do is if we want to our random number range, in order for us to ensure that we're going to get a reproducible result, then we want to kind of put in here, this is something that I'm going to add in, which is going to be the random seed that we're going to use as 45. I'm just going to choose the random seed number so that we know what it is, right? And this random seed will guarantee that we'll all have the same results coming out, okay, whatever that is. So this is happening every frame. So every frame, we're going to still have the random seed in place. We're going to come down, we're going to roll a bunch of times, right? So for I in range rolls, so rolls are going to give us the number. We're going to get this rolls number from our command line. Okay, that's what's going to happen. And then every frame, we want to do a couple things. We want to, I'm going to put the stuff in here, reconfigure, we're going to reconfigure the plot. as an example for updated die frequencies. What this means is we're going to erase it and redraw it, and we're going to change the access and stuff like that. Then the other thing we're going to do is we're going to display the frequency. I'm just putting out these as like almost like pseudocode, frequency and percentage. Above each patch. Remember what patches are? They're each bar, each color bar. We're going to have our frequency and percentages drawn above there. And that is what's going to happen every update. Okay, so that's what I want to do in there. Let's keep going back to the PowerPoint. So we've done this part, and we started doing this part. That's what we've done here, which is basically what's going to happen is it's going to roll the number between 1 and 6 in a 6-element list. Okay, we're going to store this number. Frequencies is basically going to store every time we roll that number, we're going to add 1 to the frequency. Okay, that's what's happening here. Okay, so what is this going to do? This random range thing. It's going to say, okay, I want to get a number between 0 and 6, right? Or sorry, 0 and 5. This goes 1 to 6 minus 1, which means 0 to 5. 0 to 5 is the index of the list that we're creating. So frequencies of the list, we're going to go anywhere from 0 to 5. And every time I go 0 to 5 and I roll 0 to 5, I'm going to add 1 to it. I'm going to keep adding 1. This is the tally. So frequency is going to keep track of every time I roll that number between 0 and 5. The index is going to update, 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 update for every roll. That's what that's doing. Okay, so now we're going to configure the bar, and this is going to be where we're going to follow this. Again, this is in your PowerPoint. If you don't want to wait for me, you can start typing this out on your own. But basically, what we did is exactly what I said we're going to do, which is reconfigure the bar plot. So the first thing we're going to do is we're going to clear it up. So plot.clear, the CLA. This, what it does is clear the old contents, right, of the current figure, whatever that is. Okay, so that's what's going to happen there. We clear the old contents. Remember, I want you to think about each frame and think about our bar plot as a dry erase board, a whiteboard. I'm going to go up, and every frame I'm going to clear it up, and then I'm going to redraw everything. Imagine if I could do that by hand a bunch of times per second. Then I'm going to go back, clean it again. Every time I call the update function, I'm going to clean it again, and then draw it again, and then clean it again, and then draw it again. Every single frame, every 30 times per second. I'm going to define an access variable, which is going to say, hey, Seaborn, I want to call the bar plot, right, where I'm going to pass in the number of faces, the number of frequencies, right, and I'm going to use the palette, which is equal to bright, that bright palette that we used last time, right, same kind of idea that we had in here, bright. You can use single quotes or double quotes, it doesn't really matter. All right, so this is the number of new bars. That's what this does, okay? And then we're going to say the access, we're going to set the title, set title for the access. We're going to use an F string. That's what this is. Remember the F to die frequencies. We're going to have to adjust this again. And we're going to put in a curly brace for the sum of the frequencies, right? And then we're going to use the comma, separated by commas for larger numbers. So 6,000 is going to be 6,000, and then followed by rolls. Okay, now again, we may have to adjust the spacing here to make sure that they fit, everything fits properly, but that is the title of the chart. And then we're going to say access set our X label, which is the next important thing. X label is going to be equal to the die value, right? So die value. And then the Y label, we're going to set the Y label to the frequency. So this is the stuff that we have so far, okay? And I'm going to test this chart out in a second before we move on. And then what we want to do is we want to set the access set Y limit. Remember, set Y lim, which is the Y limit. We're going to set the top equals to the max of the frequencies multiplied by 1.1, which gives us that room at the top of the chart so we can have those things printed out properly. This is going to scale the y-axis, like we said before, by around 10%. Okay. So that stuff is what we've seen. That was last day. We saw all that stuff last day when we did this. And there's really nothing new here. All right, so nothing new that we've done here. This is almost exactly what we have, except for this. This is the plot. When we clear the plot, remember plot.show is what we can use to show stuff, show the plot, the graph. Here, what we're doing is we're just clearing it up every frame, and we're going to redraw these things over and over again. We're going to clean it, and then we're going to draw it. We're going to clean it, and we're going to draw it. We're going to do that over and over again. And then we're going to make a for loop for the bar, for every bar and frequency, right? We're going to unzip or unpack the axis.patches, right? Patches again are the bars and the frequencies, right? We're going to say that the text, this is almost exactly copy paste from last week, text y is equal to bar.get get x, right? We're going to get the x value plus we're going to say bar.getWidth. This is like almost identical to what we did last week. So it produces the same kind of bar divided by 2. We can also multiply that by 0.5. It doesn't really matter. I'm going to change it to multiply by 0.5 because we're doing it every frame now, and division is definitely not as efficient as multiplication from a machine perspective, typically. So again, bar.get height, which is, that's the text on the y, and that's where the position, remember we talked about this, text x and text y is the position of where the text is going to appear, text x and text y. Then the actual text label is going to be an f string, which is going to include our frequency. Remember we did this? And depending on the frequency, if it's very large, we're going to separate it with commas. We're going to say a \n to give us a new line. And then we're going to say that we're going to calculate the frequency percentage. Frequency, as an example, divided by the sum of the frequencies. This one. And what we're going to do here is we're going to say that we're going to go to 3 decimal places. We don't have to, but it's good for us to see that that percentage, as a law of large numbers takes hold, we're going to see that that number gets closer to 16.667, right? Then we're going to say our axes.text, the actual text itself, is going to be made up. That's now here we configure. Remember, these 3 lines we're configuring. We're configuring where the text is going to appear and what it's going to say. And here we're actually going to put the text in place. So text x, text y, right? As well as the horizontal alignment is going to be equal to center, and the vertical alignment, that's going to be equal to bottom. Right now we can adjust those values to make this look different. Okay, and I'm missing the actual text, which goes right here. Okay, there we go. So that is the configuration piece, and that's going to happen every update. So that's something we did last time with a single kind of roll. We did it once, as an example. We did this number of rolls, but we did it one time, and now we have a function to do that inside of our roll dynamic dial. Let me put this up on GitHub now. So I'm going to go to here. I'm going to add this to the staging area. I'm going to go here. I'm going to say added roll dynamic .py, kind of the first draft with the update function, with update. We're going to kind of click this button here and push, which should push it up to GitHub for you. So you can always go up to GitHub and see our latest version, just in case you missed what I did or you mistyped something or it didn't work. Okay, now I want to test this before I move on. A bad thing would be to go and try and do this a bunch of times and stuff like that. Now here's something that we're going to have trouble testing. I don't want to call this update function more than once. Okay, just to test. So on the bottom of this file, I'm just going to divert from our plan and just call update. And I'm going to pass in the frame number, so number of frames that we're going to get. So for now, notice that the frame number, do we use it even here? Like, are we even using the frame number anywhere in here, right? Well, the answer is no. We're not going to use it. So here, I'm just going to pass the frame number of 1. It doesn't matter. or 0, the number of roles, faces, and frequencies. Okay, now think about what this is going to give us. Roles is for I in range of roles. We're going to roll a bunch of times. This is where the 600 roles comes into play. So this is just for testing. Faces. Okay. Curious, do we use faces anywhere? Yes, we have faces as a as our face array, right? That's what this is. Faces, remember, and frequencies. Faces and frequencies, right? So that's what's happening there. And what we want to do with faces and frequencies is we want to be able to unpack that information from faces and frequencies. All right. So remember what's happening is that frequencies right now, right, is a frequencies list, right? A list of frequencies, right? Remember? So frequencies gives us a list of from 0, right, all the way to from 0 to 6, 0 to 5. So really, we want to say that frequencies for now is equal to a list, an empty list. That's what this does, right? And we can add to that list, you know, kind of things, whatever we want to add. And we want to pass the frequencies array into there. So that's what frequencies is. That's the next part, and that's there. What about faces? Faces is also an array, right? That's what it is. Faces is also an array, right, of numbers between 1 and 6. 1, 2, 3, 4, 5, 6. So we can use that. We can say that faces is equal to an array of 1, 2, 3, 4, 5, and 6. This is going to simulate what we're going to send over to update. Okay? Update's only going to run once this time. Okay? And the way to make that run and plot some stuff out is to go here and just do plot.show, which is going to kind of push out the graph if we did everything correctly. So we're missing faces. Let's put faces in here because that's how it's going to be. It's going to be roles. Update needs frame number 1, roles, faces, and frequencies. That's what it's going to need. Okay? Roles, faces, and frequencies. Frame number, roles, faces, and frequencies. All right, let's see if this works. So we're going to say that we're going to go down here and we're going to say Python role dynamic.py and see what we get. Do we get something? Okay, it says list index out of range, index error, and it says frequencies random range from 1 to 7. Well, we don't have a list of frequencies, right? Remember, how do we initialize a list? Well, we can say, because right now we haven't initialized, we can say 0. Let's just make the zeros. There we go. So 1, 2, 3, 4, 5, 6. There's our frequency list. Okay. Again, I'm just fudging it so we can make a plot so we can see what this does, right? That's all I want to do. I want to see that this is okay. Okay, next part. We take a look and we say that we got a couple of tracebacks. And help me out, we can do this together, right? It says update 1, 600 faces. It says file line 36 in module, line 36. So that tells you where the problem is. This is the problem. We're calling update, right? And it says file role dynamic line 26 in update. So this is the stack. This is where it was called. This is where the problem is, line 26. Line 26 is right here. And it says text x is equal to bar get x plus bar get width. I spelled width wrong. It should be width. That's why I did this test, because otherwise we're going to have a bunch of errors later on, and I don't want to have errors, right? So now let's try it again. And then hopefully it'll print out the graph. Yeah? That's what I want to see. I want to see this working once, at least, you know, for this kind of thing. And you guys should see the same thing. So the question I have for you is, are you with me so far? If you're just watching, hand. If you're with me, check mark. If you're not with me and you can't make it work for some reason, X. So, okay, Anubin's watching. Tiago, you're having problems? What's the problem? Harsimon's having some problems. I see some other people are watching. Harsimon, what are the problems are you experiencing? Can I help? I want to get you guys on the same page. Let me push this up to GitHub so that way you guys can always go to my code and make it work. Okay, so again, I corrected the, so I'll say fixed bug and update. Push. Okay, so that should do that. I am using on Windows. It's showing error under Matplotlib. Yeah, that's why I don't use it under Windows. Try to figure out here what's the error. Okay, you're trying to figure out. Take a look at my stuff. Again, for the stuff I'm asking you guys to do with Python, guys, I'm asking you to do it in your Linux environment, not Windows. Windows, there are additional installation requirements to make Matplotlib show anything. Okay, it's not automatic. Just because you install Matplotlib in Windows does not mean it's going to work. Okay, I'm just putting it out there to you. That's why we don't use Windows for this kind of stuff so often. You can, but then there's different additional requirements to make Matplotlib work. You're going to have to look it up. I can redirect you later on if we have time later, and if we have more time. If I finish this faster, I'll do a Windows installation for you and we'll figure it out together. Okay? Alright, so we've got this part working. Hopefully the rest of you are good. I put up everything on GitHub so we can see that that's the case. And we know that this is going to work just like this. I'm going to have two lists, faces and frequencies. I'm going to pass those two lists into my update. That's what's going to happen, right? Frame number is something that's going to be updated every frame. This number is going to start at 1 and go to whatever number it's going to be. And the update method is going to be, when it's called, is going to update this in the frame number. Okay, so where are we right now from a PowerPoint perspective? We finished doing this. That's where we are. We finished doing all of this. And literally you can almost, can't copy paste, but you can take a look at this and go through it. It talks about the next part, which is lines 30 and on, where it talks about how do I get number of frames, how do I get roles per frame, and so on. Let's get that done first, okay? And it talks about here how to do that in this part, okay? I'm gonna get rid of this. This is just for us. I did all this stuff, right? Because what I wanted to do is show you how to troubleshoot update. I want to troubleshoot update before we get into doing the next part. Otherwise, what happens is, guys, that if we don't know this is working, and then we're like, why doesn't my thing work? Well, you haven't made the update. This is the key, the core functionality. Okay, we don't need plot.show anymore because we're not going to show update here. We're actually going to use our animation frame to do it for us. Okay, so the next is we're going to, this is in the regular thing, we're going to read the command line arguments. Right, so we're going to read the command line arguments for number of frames and the roles per frame. So whenever we want command line arguments, we're going to use the sysargv argument. Okay, I will talk about that in a second. So I'm going to say number of frames. So how many frames? We're going to say that we're going to convert to integer, because anytime we get any input from the user, it is considered a string, and that's why we have to convert it to integer. Then we're going to use the sys library, the system library, and we're going to say, hey, let's take a look at the argv array. Argv is an array of arguments, starting with array number 1. argv0 is actually the name of the file that you're running. Okay. argv1, argv2 to argvx. You can put whatever number in there. However number argument. We're expecting 2 arguments right now, right? 2 arguments, argv1 as well as argv2. And now we're going to say roles per frame. That's going to equal to an integer of sys.argv2. So what this is going to do is going to get input from the console input from the console. So let's just do this part. Before we move on, this is not going to do anything here anymore. But I'm going to say something like, if I clear the console, and if I say Python roll dynamic thing, it's going to expect 2 arguments. If I just press enter, it's going to wait. It's going to say index error out of range. There is no extra stuff. And by the way, you can catch this with a some kind of exception handling, which we're going to talk about. We can output an error saying if, for example, the number of arguments, if this is not acceptable, then we can output to the user that, hey, you need to put at least 2 arguments, and this is the thing we need. Okay. For now, we're just going to do the same thing. We're going to say, okay, I want roll die dynamic, and I'm going to say I want some kind of numbers. So number of frames, number of rolls, and then press enter. And it should just do it. It should just calculate those 2 things, and it doesn't do anything in here yet. It just takes these 2 numbers and adds them in here. So to show that, we can print that off. We can print an F string of the number of frames, right, that we printed in, followed by the number of rolls per frame. So rolls per frame. So rolls per frame. We can put that in there. We're just going to print this out to echo out back to the user what we kind of got, right? So number of frames, and then rolls per frame, comma, rolls per frame. This is just for us to get it, to make sure that whatever we enter here, we're going to get back. So again, if I was to roll this here, Python, and I press enter now, we should get back number of frames 600, rolls per frame 1, 600, 1. So wherever we entered, we're going to get back out. That's all we've done here. I'm just going to comment this out. This is just for debugging. So debug. Okay, I'll put this out there so we can see what this is, and then I'll have to kind of delete the hashtag debug to make it work again if I need to. So that's how we get input from the terminal. We get input from the terminal by using argv and argv, the different versions. If I was to print out argv0, let's print that out to show what that is. So if I said print int sys dot, actually let's just put print sys dot argv0. Okay, remember it's all strings. Let's see what that is. So if I go Python and I do this, you're going to see that's what argv0 is. Like I told you, argv0 is the name of the actual object on the command line. So it actually takes this. This whole thing is argv0. This whole thing is argv1. This whole thing is argv2, this part. Okay? If that makes sense. Okay? So that's argv0. So that's why we care about argv1 and 2. Only we care about is 1 and 2, and we want to convert them into integers because they are going to be numbers like 601. Okay? If they were going to be strings, we wouldn't care to convert them. So that's what this does. And going back to the PowerPoint, the next part is we're going to start setting up the style. We're going to set up the style once for the thing we're going to be drawing. Last time we saw we had some stuff we didn't draw, right? The values, we want to get the values and the frequencies. Remember values, we made it into an array of 1 to 6, right? Not including 7. And frequencies, we made a frequencies array. This is another way of doing that. We're going to get a 6-element array, list of die frequencies that are going to be initialized at 0. That's what this is doing, okay? So, just like before, we're going to do that. We're going to say, hey, Seaborn, let's set our style to white grid. Okay, that's what the style is going to be. Set the style to white grid. We're going to set our figure to plot.figure, and we're going to set the figure for animation to rolling a 6-sided die. Okay, so this is going to be our white background, That's what this is going to be, a white background with gray grid lines. That's what this does, remember? And this one is going to be the figure that we want to show, figure for animation. Okay. Our values is going to be a list in a range of 1 to 6. If I go 1 to 7, it's 1 up to 7, but not including 7. That's what it's going to do, with which are our die faces for display on the x-axis, right? And then our frequencies, this is the actual value, is we're going to initialize it to 0, but we're going to do this 6 times. And this is a quick way of initializing it, a list. So six element list, right, of die frequencies. That's what it's going to do. Initialize at 0, right, to begin with. So each of these lists, 6 elements, all initialize at 0 in the beginning. That's a quick way. We could have also done it my way, which is frequency is equal to 0, 0, 0, 0. Same thing. Same thing with this. Values 1, 2, 3, 4, 5, 6. That's what this is. Now this is why we want to keep this a little different than what we did. And we have values, numbers in here. But what we could also do is we could have another argument to say, okay, I want to roll dice between 1 and 20. 1 and 20. What is the frequency between 1 and 20, right? And we would do the same thing up here. We would say instead of 1 to 7, where it says 7, I could make it so that I can roll dice between 1 and 8, 1 and 20, 1 and 100. You know, how often is it going to roll? You know. So that's this part. So this part actually sets up the chart that we saw before. Okay. And let's go back to this part. So that's all this stuff. It kind of explains what each of these things are, right, in detail. And now we're going to use Matplotlib's animation module's func animation function to call the update function, right? So it's going to be the update function. It's going to be the callback function for the die animation. So here you can see it's a multi-line, a bit of multi-line code, right? And what it's basically showing is this. It says, okay, so my die animation is going to say I'm going to use the animation function, animation method, or class that calls the func animation, right, function, right? And I'm going to pass in the figure that I want, the update function. This is the update function. This is the callback that I'm going to be using. Every single frame, I'm going to be calling this function over and over and over again, right? If I want to repeat it or not, so by default we're going to say no. Frames is number of frames, whatever the number of frames happens to be. That's what I'm going to pass in here. And then there's some stuff that's missing, right? Interval is going to be the number, we're going to call this an interval, which is going to be something like 33. 33 is how many milliseconds per frame. That's what it is. If I said 16, 16 would mean that I would try to run at 60 frames per second. Here I'm only going to run at 30 frames per second. Fargs, all right, is something we have to explore as well, what fargs is, and it kind of talks about fargs down here. Or up here, maybe. Maybe I didn't put it in. Oh, here it is. I kind of went through it down here. So fargs is a tuple of other arguments to pass the function. That's what fargs is. And what we want to specify is the second argument. All right, so that is what this is, which is rolls per frame. That's the other arguments we want to pass in, values as well as frequencies. Values and frequencies we need because values and frequencies we're going to pass into the update function. So these three things, rolls per frame, values, and frequencies, is what our animation function requires. And finally, we're going to show everything at the end. Okay, let's go through that. So I'm going to go to here, and let's type the next part in. So again, we want to configure and start animation that calls the function update as a callback. That's what it is. A callback function is the function that's called every frame, right? That's what it is. We're going to call this die animation. That is the value that we're going to show. DieAnimation is going to say, I want to use the animation function, and I want to use the func animation that's built into, actually we'll make it one big line and we'll split it up later, but yeah, we'll do that like this. So what it needs is a figure, which we have, update as the callback function, right? And then we need repeat is equal to false, right? This is all part of the func animation object. Notice I'm not getting any feedback. Like animation itself is giving me nothing, no feedback whatsoever. False has to be capital F for false in Python. And then followed by the interval, which is going to be 33. 33 is how many milliseconds, right? Then we need fargs. I'm going to put this somewhere in here. Fargs. This is additional function arguments we're going to pass in to the figure, right? And that's going to equal to the following extra arguments: roles per frame, values, and frequencies. Now, where am I getting all these things? Well, look at this. Look, it needs roles per frame, right, as an example, values, that's faces, and frequencies. How do I know this? Here's values, which are the number of faces, 1, 2, 3, 4, 5, 6, and frequencies. Now, why are these called values and not faces? I don't know why they designed it this way. Okay, it doesn't really matter though. You can call it whatever you want. All right, cool. So if we did this properly, then I'm just going to put this on one line and split it accordingly, right? Then let's try it out by doing a plot.show, which is the final thing to display the bar plot. Okay. Now, this is not my code. This is a code that I'm using from the book, right? But let's see if we can get this part running right now. Okay, so again, I'm going to clear. We're going to say Python role dynamic. We're going to do 600 roles, 600 frames, one roll per frame. And there you go. And you can see how we're going to have an issue. We're having an issue. This is definitely an issue. But see, what's happening is we're definitely animating, but we're only animating number 3. Okay. And we're going to go to 600 because that's what this thing does. Now it's getting all the roles, right? All the roles here, right? But it is animating. And we're going to go to I'm going to go here and troubleshoot where I'm getting all this, well, where all these problems are coming from. So far I've got 900 and so on frames, but I'm only getting number 3 hit all the time. It's going to roll 3, 3, 3, 3 all the time. Why is that? Why do you think that's happening, guys? Well, it comes down to the number of rolls and what we're telling it to do. Okay, it comes down to that and what's happening. Okay, so let me just stop this thing. It's going to take some time to do all this, right? So we put in our animation, in our function, this random seed 45. That worked great for a one-time call, but it's not going to be great if we leave this random seed here at this point, right? So let's take that out. That's the one thing that we've changed that's different, and then run this again. Okay. Now let's see what happens. Okay, this is what I was expecting to see, right? So you can see that now what's happening is our chart is animating. And it's showing us almost like a racehorse race, like a race, horse race. That's what's happening right here. Where it's keep going, it's going to keep going, keep going. It's going to keep rolling die rolls, and the numbers are going to change. The plot, the entire bar plot, is continuously changing as things move on. And you can see that the top number of rolls, that 127 or whatever, is going to continue to roll randomly for these number of rolls, right? Now remember, we're not rolling 600 times. We're rolling one time for 600 frames, right? So remember what we did? 600 frames at 30 frames per second is roughly, you know, supposed to be 20 seconds, right? It's supposed to be 20 seconds. Now, there's a lot of rolls here. Something is not right if that's the calculation, right? Think about this. Should there not be? We only rolled a small amount, 600, and then 1. So let's think about what went wrong, and is there anything we can do to fix it? We're going to troubleshoot our numbers, right? 600 frames. 1 roll per frame is 600 rolls. I'm seeing 2100 rolls, right? Why is that? Hopefully you guys are where I am right now. You can see it's really slow, like super slow. All right, it stopped somehow at 2401. Okay, now it's continuing. So let's think about what's happening here. So for every I in roles range, I took out the above here base cell. I took out the random seed. The random seed I removed up here because the random seed was 45. So it always rolled 3. But this is weird, right? Isn't this weird? Look what we're saying. Number of frames is the first one. Number of rolls per frame is 1. So let's follow through with this. Rolls, 600. Faces, right? Frame number is right here. So that's the frame number. Okay? And do I even use frame number anywhere in here? Sorry, I'm just going to see this. Let me go back to that plot for a second. Just want to make sure that we're... because this is going to count forever, right? So let's just stop this thing. So why is it counting forever? It's like an endless loop, right? Well, look at this frame number. It's kind of... this is a good interesting part, which is it's kind of... frame numbers kind of grayed out, okay? But we do have roles, faces, and frequencies. Roles, faces, and frequencies, right? So remember, frame number is supposed to come from the Funk animation frame. That's where it's supposed to be, right? This is correct. I'm just going to look at my code here for a second. We did a plot clear, we do it, and then we for every bar, we know this is not a problem because we've tested this part out. Number of frames, put in 1 and 2 in there, so we know that the number we're getting is correct. And then we're setting up the style in the values and frequencies. This is good, right? But the problem is down in here. So animation figure, update, repeat equals to false, interval is 33, right? Interval is 33. Fargs, right, is rolls per frame, values, and frequencies, which is what it should be. And then plot.show is happening at the bottom. So if I wanted the exact same results every single time, so let's think about this, right? And let's put a way smaller number. So I want to say, I want to go 30 frames. So let's go down here and go, I want to go for 30 frames, 1 roll per frame. Okay? We're way past that already. 30 frames, 1 roll per frame, right? Because this is, look, it just tells you number of frames, 30, right? So it passes this number in here, right? It passes this number in here, And then here's our interval, 33. If I was going to change this interval number, let's just change this interval number. So from 33, because it doesn't really matter what we put in here really at the end of the day. If I change this interval number from 33 to like 16, so that means our number of frames now, this is the interval is going to basically be how many frames per second, right? Every 16 milliseconds per frame. That's what's going to happen here. Okay. But this is interesting. Update is the function we're calling as a callback. These are the things we're setting with our fargs, right? And what we want to do is we want to keep track of each one of these. I'm going to troubleshoot this in a second because something is missing, right? And hopefully you guys can see it more than I can. So let's think about this now. Let's try doing it again with a higher interval and see what happens. All right, so let us it's not liking that value at all. Let's try this again. I got nothing. See this? Look at that. Look how 16, when I make this 16, how it's like not even showing a chart. Not even showing one yet, right? So that's pretty bad, right? In terms of some kind of functionality blowout, that's for sure. And it could be my VM, but let's go for a higher number. Instead of 33, let's go for 66. So again, double slow. So instead of every 30 frames per second, double slow means 16 frames per second, right? Okay, 16 frames per second, right? That's what the interval means, every 66 milliseconds. And let me make sure that that's the case because I know that it's covered in here in terms of our roles and what they mean. So figure is the figure object in which to display the animation. Update is the update function, the once per animation frame, right? Repeat, false, terminates the animation after the specified number of frames, right? If it's true, when the animation completes, it restarts from the beginning. So this is repeat, which is here, okay? So that's what's failing to happen. And I'm going to go and check the documentation to make sure I'm correct. Figure, update, repeat, frames is equal to number of frames. Oh. Well, that's it. So that's one thing I missed. That's why it's not working. So frames, that's what's missing, is equal to number of frames. That's what's missing. And then interval is back to 33. So that's what I missed. Yeah, I knew there was something missing. Let's put the interval down here because that way we can see the interval in 2 lines. But yeah, number of frames. Remember I was saying something's wrong. I'm not using number of frames. Well, who cares? I'm getting number of frames, but I'm not really stopping myself. So let's try that now. So again, if it's 30 frames, 1 roll per frame, we should stop pretty quick. Yes, that's what I was looking for. See how it stopped? 30 frames, 1 roll per frame, we've got 31 rolls. That's pretty good. I'm fine with that. Right? It should be 30, but it counted the last one. This is the last frame that it counted. All right, let's try and get this result over and over again. By the way, if I roll again, right? So we're going to get a different result the next time we roll, right? So if I go up here and say, let's do this again, then we're going to get a different result. That's our different result for 31 rolls, right? I don't want this. I want the exact same number. And the way to do that is up here now. So here we can say random.seed. Outside of here is 45. Okay, that's what this is, random.seed. And then we can go down here and try it out. So here's what 45 looks like. 45 is going to look like this, 947524. 947524, right? 947524. Same numbers. This is reproducible, and I put the random seed up here above the die animation, not inside the update function. Okay, so pretty good here in terms of our animation frames. Okay, cool. Now let's put larger numbers. So now let's put in something that's larger. Python. Let's go for 600 frames at 1 roll per frame. Okay, so now we're going to go 600 frames. We're going to see an animation. Now it's going to keep going, and we're going to have a reproducible result. If you used a random.seed 45, then the final frame number, which is at the 600 frame mark, 601 actually, is going to show the final numbers, whatever those numbers are going to be. Okay, but you can see how the number of the frequency of rolls is going to be the point where we're going to see that same distribution that we saw last time. Look, 90, 93, 102, 104, 102, 110. Which, remember when we first did 600 rolls, it was roughly like this. Why? Because we have 110 sixes, the 6 is coming up more times than the 1 with this random seed 45. Okay? And if I put a different number in there, let's say, for example, I want to put in, for every frame, I want 2 rolls. So 2 rolls per frame. Okay, let's see what that does. 2 rolls per frame, that's going to be, you see that it's a little bit less smooth now because it's trying to calculate more things per frame, right? But now we're going to we're going to be double the amount of rolls. So this is going to stop at 1200. Okay, 1202. Make sense? So that's how it shows us what how the rolls fall, and it looks like at 2 rolls per frame, we're going to see that number 2 is really climbing a lot higher. Okay, so let's keep going back to the PowerPoint for a second. Let's keep looking at this stuff. So frames, again, first thing is the figure, the update. Those are the options. Repeat, false. That's important. This definitely should be false. Right? Frames is the total number of animation frames, which controls how many times the func animation calls update, right? The update method, right? Passing an integer is equivalent to passing a range. For example, 600 means range 600. That's what it does, okay? Func animation passes one value from this range as the first argument in each call to update, which keeps track of what's happening. It's almost like a call that's a reference call, okay? Finally, interval, the number of milliseconds, in this case 33, between animation frames. The default is 200, it says. Right, that's really slow. 200 milliseconds per frame. Really, really slow. After each call to update, func animation waits 33 milliseconds before making the next call. That is the waiting period. That's what I said. But it seems as if we can't go to 60 frames per second. Fargs, or fargs, short for function arguments, is a tuple that passes the rest of the arguments to the update function. That's what happens. All right, so let's take a look at that func animation function. So I said matplotlib animation func animation function. And this is the function, the way it works. So the frame is the first part, and fargs is the second part. And notice that it's an iterable, that we're going to get over and over again. Okay, that's how this works. And notice it says we're going to get frames is none, int underscore func is none, fargs is none. These are the defaults. Save count is none. Cache frame data is true. Okay, that's what it says, frames. And it says int func, callable optional, is a functional used to draw a clear frame. If not given, the results of drawing from the first item in the frame sequence will be used. So look where that falls, that init func, right? So init func, remember we said we have our figure, our function, and our frames. So let's take a look at what we have in our example, right? Our figure our function, and our frames. And then we have something else. Repeat, interval, and fargs. Repeat, interval, and fargs. Well, we didn't see that here in our function. Fargs, a tuple or none, is optional additional arguments to pass to each call to the func callback function. That's what that is. Interval, a delay between frames in milliseconds, defaults to 200, but it doesn't say what the interval we can do is. Seems like when we put a larger interval or smaller interval in there, like 16, doesn't really like that. It's definitely a number, which means it can take, not just an integer, but anything else we want to put in there. Repeat delay. If the animation is repeated, adds a delay in milliseconds before repeating the animation. Repeat is true. Blit controls whether the blitting is used to optimize drawing. Okay, so note when using blitting, any animated artist will be drawn according to their Z order. All right. However, they will be drawn on top of any previous artists. Artist means like their stuff that they're drawing, their frames. And cache frame data controls whether the frame data is cached. Defaults to true. Disabling cache might be helpful when frames contain large objects. Okay, so there's some objects we can use here. And what I want to try and do is blit. So blit right now is optional, which means it defaults to false. Look at that. Let's blit true and see what that does. So blit means I can add another argument in here. Let's put before interval. These are named arguments. Blit equals to true. And let's see what the difference is when we run the same thing here. Does it give us better performance? It says, actually, traceback line 258 of backend GTK3 pi in size allocated. It says, and this is the stack. So it says draw frame, raise runtime error. The animation function must return a runtime error. The animation function must return a sequence of artist objects, right? And that's why blit is not working, right? If you go through this, it tells you which of the Python libraries are not working with the option that I put in. So blit, not a great option for us to use. Blit true, right? Even though it's part of our documentation, and it says it's optional, it just returns a bunch of animated artists. Now, what that means is, if I look at this thing here, right, cache from data is true, and then kwargs is really a number of variable arguments that I can add. I can add more stuff in here if I want. Okay. It returns an iterable of artists. That's what it returns. If blit is equal to true, function must return an iterable of all artists that were modified or created. And this information is used by the blitting algorithm to determine which parts of the figure have been updated. The return value is unused if blit is equal to false and may be omitted in that case. So what we're saying is that this function here, which is die animation, is, it actually is something. We're getting a return value, and that's what's happening. Die animation is a thing that's basically is going to be representative of this whole thing. So blit true, not something that we can use without changing our algorithm a bit. All right. What about if we change this interval like we tried last time? I want to make this interval 16.66667. Can I do that? Am I allowed to make some kind of point here? Let's see if that works and what happens when I do that. So last time it ran no problem with 33, but 16.6667, anything less than 33 seems to be giving us an issue. And it could be machine dependent. Remember, we're running in a virtual machine here. Maybe my virtual machine can't run that fast. Just can't do it, right? Maybe if you're running Windows, it's going to run no problem. But for me, 16.67, it actually just does everything at the end. It just does it, and then here it spits out the result. Can't update fast enough is what my problem is, right? So 33 seems to be the fastest that I can probably update. Let's try a smaller number. So instead of 16.667, let's try some other weird number like, I don't know, instead of 23, let's try 26. And let's see what that does, if that helps me in any way. I don't think it's going to help, guys. Like anything lower than 33 seems to default to like not printing out what it's showing us, which defeats the purpose of doing a dynamic, kind of allocation, right? Like it's going to come up eventually after that many rolls, right? Remember, it's going to go to 1200, and there it is, 1200 rolls, right? Notice the number is exactly the same. So that's not going to help us. So let's go back to 33. 33 seems to be the right number for my virtual machine. Okay, if that makes sense. Okay, but let's increase the number. So I want to go for 600. I want to go first of all to 1,000 rolls, or 10,000 rolls, right? Or 10,000 frames. Okay, again, let's think about what we're doing. 10,000 frames, 1 die roll per frame. So divided by, as an example, 30 frames per second is this how many seconds, divided by 60 is roughly 5 minutes, right? 5 minutes. 1 roll per frame is 10,000 rolls. Okay, that's what's really happening here. We want 6 million rolls. Okay, so if I said 10,000 frames and I want to do a larger number, like 600 rolls per frame, can my machine handle this kind of crazy calculation? Let's see what happens, right? And now you can see that indeed it's really rolling as fast as possible, right? 600 rolls per frame, dudes, right? So you can see what's happening here, right? 600 rolls per frame, and then you can see we want to go 10,000 frames, right? Which is roughly 5 minutes. This thing is going to run for 5 minutes before it's done. Okay. Well, you can see what's happening already. The law of large numbers has taken hold very quickly. Remember, just after around 100,000 rolls, this is pretty good, right? And it quickly jumped there. It was like there almost immediately, well, because of the number of rolls per frame. So we're actually rolling many, many more times every 33 milliseconds. We're rolling 600 times, right? So if that's true in 30 frames, take that 600 and roll it 30 different times, right? 600 times 30 frames per second. So each second, what's happening now is if I go back here to my calculator, if I take 600 rolls, right, and this is per frame, 600 rolls per frame, and multiply that by 30 frames per second, we're looking at 18,000 rolls per second. 18,000 rolls per second, guys. And if I multiply that by 60, which is a minute, we have 1 million rolls per minute, and multiply that by 5.5, we're roughly equal to about 6 million rolls, right, in about 5 minutes, which is what is showing here. You can see how the numbers are getting closer and closer to the top. Okay. Now this is a different visualization. Depending on what we put in here, it's a different visualization depending on what the numbers that we use are, right? But again, what this is showing us is, the number of rolls. It doesn't matter what the, in this case, what the random number seed is. It really depends on the earlier part. But once we go to this number of rolls, we can see that this is going to go pretty quickly. So that it's almost very even. See that there's some that is a little bit larger, like for example number 2. So the 2 on the die seems to be rolling more than the other ones. And what we want to see is 6.666, right? And so that number should drop as we approach 6 million. It should drop. Instead of 16.7 something, it should be 16.6 something, like the other ones. Whereas you can see clearly, like the number 5 here, right? So how many times 5 has been rolled is less than 2. 2 is higher than 5 in terms of number of rolls. But you see that this is slightly going up slowly. It's increasing, and slowly this should be decreasing because it's supposed to be equal pretty much around the top, at the top. Okay. So this definitely is one way of doing it, is how many rolls, how many frames, and how many rolls per frame. Okay, so I'm going to stop this because it's going to get to that number at some point in time. Let's try it again with a different number. So let's say instead of, we'll go back to 600, and we'll do it the other way around. 600, how many rolls per frame can I do? Can I do 1,000 rolls per frame? We did 600, no problem. How about 1,000? Well, yeah, now you're going to see the numbers go from a lower number, and it's going to go, you know, to a number higher. So more rolls per frame, but less total frames. So again, you can see it the other way around. So we have 600 frames, 1,000 rolls per frame. So 600 frames divided by 30 frames per second is roughly 20 seconds of time, right? You see it stopped. Multiplied by, so 1,000 rolls per frame. So 1,000 rolls per frame multiplied by 600 frames is equal to 600,000 rolls, which is right there. See that resolved a lot faster. 20 seconds, okay? I want everything to resolve in 30 seconds. If I say I want the whole thing to last a minute, to go to 6 million rolls. 6 million rolls. So how would I do that? If I want 6 million rolls, right, and I want it to last a whole minute, that's 60 seconds, divided by 60, right, is 100,000 rolls per second divided by 30 frames is roughly 3,000, well, it's exactly 3,333 rolls per frame. 3,333 rolls per frame, right? Okay, 3,333 rolls per frame is something I have to accomplish. And then if I did 3,333 rolls, how long would it take? How many frames do I need for 1 minute? So 1 minute, as an example, is 60 seconds. 60 seconds times 30 frames per second is 1,800 rolls. Okay, 1,800 rolls, 3,333. Those are the numbers. 1,800 rolls times 3,333 rolls per frame. Let's see how this works. So we want in 1 minute, we're going to have, you can see that there's some animations part is skipping because my machine can't handle that many rolls, my virtual machine, at least the visualizations behind it. You can see we're already at 1.8 million, but we're going to have 6 million by the end of a minute. The result is going to be the same. The result at the end, because we're using a random.c to 45, is going to be the exact same number every single time. And we're going to be very close to 6 million. We're going to be just under 6 million. Because I used 3,333. I didn't use 3,334. If I did that, it'd be over 6 million. We're going to be just under 6 million here at the end of a minute. And that means each column is going to should have about 1 million rolls each. There we go, 6 million rolls. Actually, it's over because of the extra numbers that we're getting, right? That's pretty good, right? So we're looking at the numbers, the law of large numbers, 16.66, 16.65, 16.65, 16.67, 16.657. Still, even for 6 million die rolls, right, as an example, it took us a minute of visualization, right? If I gave it more time, instead of a minute, if I multiplied if I halved the number of rolls, so instead of 3,333, I halved it. I said, okay, I'm going to do only, instead of 3,333, I'm going to do 16,667, like this, right? So I'll try it again. So, and then I'm going to double the amount of rolls. So I said, okay, I want to do 3,600, right? 3,600 frames, right? And I want to do half the number of rolls. So 16.66, you know, as an example. Let's make it 16.66 and then try that and then see what the difference is. Here you can see that there's more dynamic, there's more movement, right? And it's a little bit smoother. Why? Because I have less rolls per frame. So I can see more things happening. The more rolls per frame, the less animation movement I'm going to see. Look, even it stalls here anyway. Remember, it's keeping track of all these numbers, right? So again, now it's going to be 2 minutes. It should be approximately 2 minutes before we see the 6 million result. 2 minutes. So why am I going through all this over and over again? Because this is a a lesson in how you calculate number of frames, and we're going to get to more dynamic visualization later on in this course. And it's good for you guys to understand how things work in terms of number of frames and number of rules per frame. Every frame is every 33 milliseconds right now, because that's the fastest my computer can visualize it. If I was to drop this number, my computer won't visualize it. Not my VM, right? My VM won't handle it. It can't do 60 frames per second. Okay, so this is proving the point. It's going to run for 2 minutes. I'm not going to keep doing this. I am going to put this up on GitHub though, because I think it's good to do this so you guys have this visualization. Let's do this thing. So I'm going to say git add dot git commit -m, and we'll say updated or fixed bug in animation function, which is what I did. Git push origin master, which should push everything on GitHub now for you guys. So you have everything by the completed code, and then you guys can try it out. Random number seed 45. You'll get the exact same results I just did every single time. Questions around how this works? Any questions around the problems? And there's some other problems that we also saw in here. This is not perfect. We saw that the number of roles went beyond the numbers we calculated. We said, okay, it's only going to be 600 roles, but actually it's not, right? It's not just those numbers of roles. And we went over that amount every single time. We didn't just do 600. If I was to run this with smaller numbers, for example, if I went back to here and I said, I want to roll 300 frames, right, as an example, and then 1 roll per frame, right? Or like we said before, 30 frames, 1 roll per frame. So that's like 1 second, kind of thing. It should be done. There's 30, but we get 31. Why are we getting 31? 1 roll per frame, 30 frames we're rolling, and we're getting mostly ones. Actually, you got a lot of, this would be a very bad result if you played Warhammer. Right? If you're playing Warhammer 40K or something, this is like bad. Nine ones and not very many not very many sixes. Not good, right? Actually, it really depends on what you're trying to do. But if you're trying to roll sixes, that would be bad, right? That would be a bad result. So why is this? Why am I getting 31 rolls instead of 30? Okay, well let's do one more thing before we move into the Windows side. So again, we said 30. It's taking an argument of 30 in here for number of frames, right? Number of frames is passing in the frame number to here, 30, right? And that is the limiter, number of frames, right? Now, maybe if I put number of frames -1, let's try that. Number of frames -1, because I'm getting, this could be a counter, right, of some kind. And if I was to do that and said, okay, I want 30 frames, it's going to stop exactly at 30. Right, there we go. Okay, what about if I want 60 frames? Does it also fix that problem? So 61. So I want 60 frames and I want 1 roll per frame. It should stop exactly at 60. So it seems that is the issue, right? And that is pretty good. So we can see that that's really, look at the 14s. Let's just try this, guys. Try changing this number of frames -1. Put that in there. And instead of putting the number of frames, so because it seems to be we're getting an extra value, okay? Try that, and then on top of that, try with our random number seed 45, right? Random seed 45. See if you get the same result. Do you get 14, 14, 14? That's awesome. What a weird combination of numbers, right? Just roughly. And if you do, then you're good to go. You've done what I've done. Okay. That's another bug I'm going to fix. I'm going to say git add dot git commit -m. We made it our own now. We kind of made a few changes, right? We're going to say that fixed number of frames bug. Git push origin master. That pushes everything up to GitHub. You'll have everything I have now when it comes to doing this dynamic visualization. Okay, great. This is a good exercise. And I want to try, kind of installing stuff on on Windows really quickly because people are having trouble with using Python. And let's see what I can do to make how much trouble there is to install Python on Windows. And there is a lot of trouble. Let's like shut this down. And if you have to go after this, because we're going to time out, we are 4:07. We only have another 13 minutes. And you might think 13 minutes is enough time to load everything with Windows, but let's take a look at this. If I go, first of all, do I even have Python installed? So if I type the words Python in here, do I get anything? And the answer is no, I don't. Microsoft door comes up and says, hey, do you want to get Python 3.8? That was just me typing Python at the command line. That's how smart, Windows has become, right? Maybe you want Python 3.8, it's saying. Okay, let's just use this. I'll say, sure, I'll take Python 3.8. Let's get, right? Microsoft is go online and it's going to say, okay, cool, if you want it, let's install it. Again, I'm just using the Microsoft store here. I'm not doing any work. Sorry, let's take that back. I'm doing very little work. All right? So first thing is, can you get Python installed? First thing, okay? Next, let's close this window down and relaunch, right? So we're going to say command prompt Python. Do I get Python? Yes, I do. 3.85, which is pretty good, right? So I've got Python now installed on Windows. That's done. Cool. I've got Python installed on Windows, but now I need Matplotlib and all this. I need pip. So how do I install pip on Windows? Because I'm trying to do the same thing. So install pip Windows. How do I do that? So pip on Windows, it's pip, and here's the prerequisites. Windows or Windows Server, access to command prompt, pip help. We want to go to Python 3.7, testing it to Python's there, and then download pip get pip.py, right? Before installing pip, download to the get pip.py file, all right? So what is this thing, right? It is a little script that they've given you here on Phoenix Nap. I'm just randomly going to a site to do this, by the way. So this is the script. It actually does your pip installation for you, right? Okay, sure. And if we assume that this is one way of doing it, that's okay. Let's see if there's another way of doing it. Let's see if there's not another way to do it without using that script. So Python, and no, it looks like everyone's using getpip.py so far, right? So I'm just trying to see that if there's another way of installing pip, right? How to install pip on Windows. Again, I'm going further down. Check if pip's already installed. It's not. Python version. And okay, so it says to manually install pip on Windows, you need to get a copy of getpip.py. Guys, this is the same exact thing that we've seen like 10 times or 3-4 times now. So maybe the first installation wasn't a bad idea. Get pip.py, right? So that's the first thing. I want to get pip. I need to get this pip.py stuff. So let's download it, this thing completely, right? So let's try this out. Instead of doing this, I'm going to right click and I'm going to say save link as. Let's put this somewhere we can find it. I'm going to put this on my desktop. All right. Actually, yeah, let's put it on downloads, not desktop. Yay, there's getpip.py. Okay, cool. Let's go back to my command prompt and go to downloads, right? And then run that thing. Python getpip.py and then run. Let's see if that works. It downloads stuff. It goes through these commands. It asks me for some warnings. It says, warning, you're using pip version blah, but however, version 20.2 is available. You should consider upgrading via the Python exe pip install upgrade pip command, right? So Python -m pip install -- upgrade pip. That's what it's basically saying for me to do. It says requirement already up to date, right? It's already installed. So if I say pip -- version, we should be able to get this, pip 20. Okay. Now that we have pip installed, Python pip, right? Doesn't work like that. It just says pip. Pip's enough. That does it for me. Pip does the installation of what we want. We can do the next part, which is Matplotlib. Install Matplotlib, because we don't have that. Matplotlib with pip. Right? So this is the way I would do it. Install with pip, which is, I'm going to do it my way. I could have done it a different way, but I want to do with pip. This is the way that it's done here. Get pip install matplotlib is all I need to put in there. That's the command, right? So let's do it. So clear pip install matplotlib. Now remember what pip's going to do? It's going to grab dependencies and it's going to install all the dependencies. Look, pillow, numpy, cycler, kiwi solver, pipe parsing. All those things are in place right now. It says, warning, the script f2py is installed, which is not on the path. It's not on the path. Consider adding this directory to the path. If you prefer to suppress this warning, use no warn script location. So what it's saying is it's inside f2py.exe, which is not on the path, right? Which might cause me a problem later. Might cause me a problem later if I didn't do that. Let's continue. Let's add Seaborn now. So pip install Seaborn. Remember, this is the next one. Seaborn. And grabs Seaborn and loads it in. And it's got all these other requirements that are met. And it's actually loading installed collected packages. Right? It's looking for SciPy, Pandas, and blah, blah, blah. Waiting for us to finish the installation. Again, this is using the full power of my processor compared to using something like, a VM, right? And pip install -u, which is what we did before, -u scikit-learn. Okay, so this is kind of going through, updates everything needs to be updated. It says, whoa, bam. Error. Could not install packages due to environmental error. No such file or directory. See users, app data, local packages, Python software foundation, local packages, local cache, site packages, sklearn, data sets, test, data, OpenML. Look at this. Okay? And then it's something like I'm missing something. Okay? So let's look at scikit-learn and see if there's another way of doing it. So scikit-learn install Windows pip. All right, and again, I don't need to install scikit-learn, but what the heck? So it says do it like this, which is exactly what I did. Pip install -u scikit-learn. In order to install and to check my installation, you can use the following: Python -m pip show scikit-learn to see which version you were installed. Let's just do this part first. Okay, so let's try this. And then you can see that my package did not get installed, right? Python -m pip show scikit-learn. We had a problem installing it because of this problem here, right? So scikit-learn has already had a problem installing, right? It says that it's an environmental error, right? Which is the users, this package 3.8 local cache, and it says that it's something that's missing. All right, so if I try installing it one more time, and I might have to do it with something like administrative permission. Let's try that out with administrative permission. So I'll try and run my command, but I'll run it as an administrator and see if there's a difference. I don't think it's going to make any difference to my problem, right? But let's see what happens. Anywho, so I'm going to say pip install. We'll say pip -u. Pip -u install scikit-learn. No option -u. Did I not do this right? I just did it the wrong way around. Yeah, so it's nothing to do with my installation from an administrative rights perspective. It just, there's some file that's missing. This is troubling, right? Because once I get to this, and if I can't install something, and this is why I told you Windows installation sometimes not a happy thing for Python. So if I run a couple things, one thing is I want to try a Matplotlib test, Matplotlib. Just want to do a regular Matplotlib thing. And we can see that there's the installation instructions, right? Which is what we did. We did this part stuff right here. And we want to, it talks about dependencies and some other stuff. And what we want to do is want to test out how we can use Matplotlib. There's documentation. There is a tutorial that we can do for a usage guide. Let's take a look at that usage guide and just try these two things inside of a file. So we're going to go to our, somewhere over here. We'll kill this thing, and we don't have any other ones up there. We'll make a new thing for this. Is again using Windows. So we'll say COMP301 test. Here's our new folder structure. We're going to pull in VS Code in here and drag and drop. This is without using Conda or Anaconda or anything. Anaconda makes it a lot easier than this. And we're going to make a new thing called test.py. Actually, make it main.py. Main.py. Right? And we're just going to copy paste what we have from Matplotlib, which is these two things. So this. So paste, right? And automatically we can see there's an issue. Look at that. It says Matplotlib pyplot as plot doesn't compute, right? Now, one thing that we didn't do is we didn't configure our VS Code thing. It actually asked us to take care of this for us. It said there's a problem with Python, right? Oops. There's a problem with Python, and it says auto detect, but configure my my stuff for Python. Let me just get rid of this for a second and open this up. And what it did last time, it says, well, we don't know what you're configuring your Python installation for. It's actually this, right? And now we're good. Okay, so that's the one thing. You have to configure your Python installation to match the Python that you have in here. This is good that we're able to find Matplotlib, and then we want to do exactly these things here. These two things, so copy and paste, right? Which should show us everything we need. So if I just go here, and if I go command backtick and run Python, you see Python is running indeed. And if I do python main.py, then we should be able to run main.py, configure it, and show a plot, a graph, but we get nothing. We get nothing. And this is where you guys are when you're saying, Tom, I don't know why, but whenever I run something in my Python, well, it doesn't display Matplotlib, something is missing. Yes, it is. There's stuff that's missing in Windows to make it work. There's no visualization component right now using this, right? So let's see what the problem was. So again, we can go back to Troubleshoot, Matplotlib, Windows not showing, right? Not showing up, sure. Resolved. Okay, let's see what the problem is for not showing up, right? No plot found, but we don't get any warnings, and it says that these are the things that it needs, right? And not showing up or displaying. Matplotlib backend, it does all the heavy lifting for scenes to prepare the figure. Popping into a shell, I can access the Matplotlib backend by using this, right? And so that's something that we have to look at. Something is not working on the back end to produce Matplotlib, graphics, and that was that one element, right? So let's see if I can say matplot show, or plot.show in here inside of thing, because that's the problem. We have to kind of Google it and fix it, right? So I don't think plot.show is needed for this, right? Because plot.show, we don't have nothing much to show here, right? So let's try this out again. Oh, there we go. Okay. I'm good to go. And now that I've got this on Windows, I should be able to crunch that same program. So let's download the program. Sorry guys, I know I'm taking an extra minute. But let's download the program from GitHub on Windows. So I'm going to kind of close everything up, and I'm going to go to my command prompt, and I'm going to say that I want to go to my desktop. So go to OneDrive, go to desktop, and I'm going to say git clone https //github.com/ Centennial College, and then / the name of my app, which is COMP301-M2020-lesson10.git. And if I did everything correctly, then I've downloaded this project. Here it is. This is the one we just did, right? And I can simply just open up, if I did everything correctly, drag and drop this project into VS Code, right? And you can see now we have everything we did from today, right? So theoretically, I should be able to run this in my command prompt. And if I say something like Python, and then it is roll dynamic die.py, I want to do 600 rolls, and then by one roll, so 600 frames, one roll per frame, we should see a dynamic visualization come up. And there we go. Now you can see that there's a much smoother visualization that comes up because, again, I'm using the full power of my system. I'm not using a VM, which is giving us a smoother, kind of result, right? Again, a VM, there's limitations, but here you can clearly see that I'm getting more visualization. I see every roll that's being done, as opposed to only some of the rolls and skipping rolls, because remember, my VM couldn't keep up with how many rolls were happening. So this is why I'm seeing a much smoother takeoff from what I had before. Again, this is in Windows. Okay. But what if I want to have a faster frame rate? That was a problem that quirked me on the Linux side. Let's say if I want to go to 16 as an interval, can I do that now, or will it do the same problem? This is the big test. And yes, indeed, I can do a much smoother animation and many more frames. Because I'm running at twice the frame rate, I'm going to finish way faster, and it's also going to be way smoother. So I'm actually running at 60 frames per second. Okay, cool. What if I wanted to run at 120 frames per second? Okay, now now it's just crunching power. Remember that I'm running an i9 10900K with 64 gigs of RAM and a NVIDIA RTX 2060 Super, which is my temporary video card for now. So, not that the video card really matters, the GPU is not being used, it's more all CPU stuff that's happening, right? But that is like my CPU going, and I think my CPU is running at around, it's still green, it's running around 65 degrees right now, so we're pretty good. Plus it's also broadcasting, doing other things, right? So let's see if I can do that now. So this is 600 rolls. Let's try running it at 120 frames per second, which would be like an interval of 8 milliseconds, right? So every 8 milliseconds we're going to run the same number of frames. Let's try this out and see if that gives me 120 frames per second. Again, I'm halving and halving and halving, right? So I'm running 120 frames per second now. The result is going to be the same, but the time frame is going to be halved. Okay, now I need to do this because I'm only rolling one time every frame. Now I'm going to go with some crazy numbers, right? I want to do some crazy numbers. I want to get, knowing that I have, and this is the last thing I'm going to do today, guys, knowing that I want to reach 6 million frames, 6 million counts, count is 6 million, right? And I want to do it in a minute, so divided by 60, so 60 seconds. I want to do 100,000 rolls per second, divided by a count of, again, 240 frames per second, which is what I'm counting right now, right? So remember that the way it works is I'll have to roll 416 times per frame to do that over whatchamacallit, 60 seconds. So 416 times. So how do I know it's the frame count? Well, look, we're at 8. 16 is 60, right? 8 is 120. So it's 120 frames, sorry, not 240. Let's try that again. If I go down to 4, let's see, can I even run 4? That's 240 frames per second. So increase frame count. Way faster, much smoother animation, but we want 240 frames per second. So this is working, so I can do 240 frames per second. That's like a way smaller number than what we were running with before. Much faster, right? Again, let's do that count. So 6 million, which is the number we want, not 60 million. 6 million divided by 60 seconds, so in 60 seconds I want to be at 6 million, is 100,000 rolls per second. Divided by 240 frames per second is roughly 416 rolls per frame. Okay, so 416 is the one on the right, this value, 416. Now how many frames do I have to run if I'm running at 240 frames per second? So again, I want to run for a whole second, right? So 1,000, right? 1,000 milliseconds divided by 240 frames. So roughly 4. Does that make sense? Number of frames. No. How many frames are in a second? So 240 frames, it's the other way around. 240 frames times 60 is 14,400. That's more like it. 14,400 is what I want to put on the left side. So again, let's try this out. So Python 14,400, and then what do we say? 416. Just calculate that one more time, because I lost track of that count. Divided by 60 seconds, divided by 240 frames is 416. So 416, and go. Let's see what happens. So we want in a minute to go to 1 million frames, to go to 6 million, and you can see that it's doing it, guys. It's doing it. It's doing this many calculations, and I'm handling it without even a bump in my performance, right? To see the performance that I'm running, this is total performance, right? Control Shift Escape will bring up my performance numbers, and you can see under performance what my CPU utilization is right now. My utilization is a total CPU of 39, 33. So it's not even coughing too much. Like I'm still well in. I'm also broadcasting. I'm running OBS. I've got I'm pushing to YouTube. Doing crazy stuff here, and it's still running no problem, right? And again, I'm only running at a clock rate of 3.7 gigahertz. I'm not overclocking at this point, which I could totally do, right? And yeah, if I want to go for my resource monitor to see each CPU, you can also do this. You can look at each of your CPUs. I've got 10 of them, right? Or 10 cores, right? But there's 20 threads. You can see that some of them are running more than others. Performance monitoring also can work as this is keeping going here. It keeps going, right? We're still at this many rolls, right? Let me just bring this down for a second. You can also use something called hardware monitor. Sorry about that. Hardware monitor will also bring up this, which will show you things like GPU temperatures, as well as the GPU utilization right now, which I am utilizing GPU because I'm broadcasting live, right? Which is pretty cool. It tells me my fan count, my fans for my GPU, which is kind of going on and off. There's only 2 fans that I'm monitoring right now, or 2 GPUs, and so on. You can see now I've made my 6 million rolls, right? Or did I do 6 million or 600,000? Did I miscount? I miscounted somehow, because it stopped just shy of 600,000, guys. Just letting you know. Let's try that again. So 1440. Again, this is assuming that my frame rate is correct. So let's say a frame rate of 240 frames per second. Let's try that out. So milliseconds in 240 frames FPS. I think pretty sure it's like 4, right? No, that's meters per second. I want number of milliseconds for 240 frame per second. Yeah, like I said, 4.1 milliseconds. That was right. So that is the correct interval, right? But my calculations maybe are wrong. Let's try this one more time. And then I'll stop, I swear, for the day. Right, so again, calc 6 million, not 600,000, 6 million divided by, so 6 million rolls in 60 seconds. Didn't take 60 seconds, it took longer, right? So 100,000 rolls, right, every second. 100,000 rolls every second divided by 240 frames is 416 rolls per frame. That's the number that's here. Okay, cool. I have 240 frames and I want to run it for 60 seconds. It's going to be 14,400, not 400, 1440. I was incorrect. So 14,400, that's more like it, times 416, run. All right, I'll let that go for, again, it should be a minute of time before it gets there. But you can see again, if you look at my utilization that I've got going on, this is my hardware. You can actually download CPU ID hardware monitor to take a look and see what you're running at, right? If I open up my Comet Lake, it's what I'm running. So I'm running a Z490 motherboard, right? You can see that my overall CPU utilization on average is roughly, like for all my thread count, all my threads, is roughly an average of 22%, really low, right? Hey guys, is this taking a minute, or is this longer than a minute? What do you think? To me, it feels longer than a minute, but you know, again, I can't tell because I'm not counting seconds. And we're still only about 300,000 since I started, so. But not bad from a utilization perspective, huh? The great thing about it is the smoothness of the animation. I'm running 240 frames per second, roughly, as I'm trying to anyway. And you can see that we're seeing every roll. We're seeing a lot of rolls happening. We're not skipping too many, right? Which is really good, because before on the VM, we were skipping large quantities of rolls, right? So lots and lots of rolls per second. All right. Yeah, it does feel longer than a minute. And why? Because we're also visualizing. So we're actually losing some performance. I don't think it's really reaching. We're trying to do 240 frames per second. I don't think it's doing 240 frames per second. I think that's the key, right? This isn't utilizing that kind of power. Why? I don't think it can do. I don't think Matplotlib and the algorithm can run that fast. I don't think it's optimized for running that fast. So it's going to take longer. Look, we've already surpassed 600,000 rolls like the way we did last time, but I don't think it can run that fast. So again, we'd have to measure it and what the actual time is. And if we actually get the actual time, then we'd know the frame rate. But I don't think Matplotlib can do it that fast. Still, it's pretty good, and we're getting the kind of closer and closer to those numbers. You can see again the same pattern because we're using the same random number seed. That number 2, or the 2 face on the die, is being cast more than anything else right now, right? 16.7 compared to 16.6 is everywhere else. Okay guys, that's it for today. I don't want to go too much crazier than this. Thank you so much for coming on. Remember that next week, Thursday, is the next time we'll meet, which I think will give us a chance to discuss kind of your assignment, which is due on that Friday. And what we want to try and do going forward is talk about the next assignment. Okay, so let's get together next week. Guys, thank you so much. Enjoy the long weekend. Well deserved. And I'll see you guys next week. Take care. I'm going to stop recording now.